try not to overlap. I'll overlap a little problem. Okay. For those of you who weren't here, I'm Ron Payne, W6YOU. Another one of the sixes that didn't change his call. Because I was going to go back to California. So much for that. All right, basic dipole theory now. I guess we can do some math here. There is our basic formula for a dipole. 468. Very easy to remember. 2468, 468. And like I said before, the actual number is 492. But that doesn't take into it, that's in free space. This one takes into account more of the fact that you have insulators on the end and you're making it out of wire or pipe. The good news about this formula, in my 53 years as a ham operator, I have never had to add on wire. Never. This always cuts it a little long. That's the good news. So I always try to pretty much measure right what that says and never worry about it. And I always end up snipping some off. All right, now a little theory. I get the question all the time, even from engineers in my class, what's so magic about half wave? What's that about? Can't we do full wave? Can we do 3/4? Can we do 6 wave? Yeah, well, we can, but we want to make a dipole here that we can feed with 50 ohm coax, so let's see what we can do here. First off, we're going to take 2 wires and run them opposite directions, connected by coax, and we have the radio source. And this is the formula, and many of you saw it on your test. It's the formula for inductive reactance. That's X sub L. It is in ohms. And one thing we do know about X sub L is that as the wires go out this way and as current flows down those wires, inductance goes up. That's the law of electronics. You have current flowing down a wire, it causes inductance. The longer it goes down, the more inductance. Well, as the inductance goes up, the inductive reactance goes up. Everybody with me so far? On the other side here, the antenna also has capacitance. The farther away the 2 wires are, you have a capacitor here, and a capacitor here, and a capacitor here, and a capacitor here. And of course, as it goes down the wires, the capacitance gets greater. Now it gets crazy. As capacitance goes up, capacitive reactance goes down. It is a negative number. Okay? Well, there's a magic place down the wire based on the frequency you're using where the X sub C, which is negative, will equal the X sub L. And they will cancel each other, thus 0 reactance. And when you have 0 reactance, you have resonance. And that's pretty much what we're all looking for. We're just all bent on VSWR in here. So resonance, the true definition, is the frequency at which the dipole feed point is purely resistive. And of course, since we're feeding our dipoles with 50 ohms, I guess 50 ohms is pretty much what we're looking for here in this room. Any questions on this? So a little bit of a background in electronics helps. We have X sub L, X sub C, okay? So there's this one magic point. By the way, we have a radiation resistance just due to the fact of electrons shooting down the wire. So you have your R sub R, your radiation resistance. And one other thing we've noticed that just a little bit less than a 1/4 wave. A little bit less. So any questions on this? Okay. 1/4 waves times 2, half wave at resonance. So if your antenna is cut exactly to the frequency that you mated for, the current will be maximum in the center and pretty much zero at the ends, okay? This is not a DC circuit. I think most people, and even most of my students, don't realize that an antenna is a circuit. It's a series RCL circuit. Well, with that in mind, remember how easy DC was? Current, voltage, flow, and phase are together. That's the easy part of school. When you started getting into AC, that's when all your friends that couldn't do math quit being an engineer and went into business. Yeah, I remember that. Current is maximum in the center of the antenna, and 90 degrees out of phase at resonant is voltage. Voltage is basically zero in the center, but very high on the ends. Every year, I have students who forget and go touch the ends of the dipole while I'm transmitting. Is this the antenna we're using, Mr. Payne? Well, you don't get a shock. You guys know that. You get a burn, and the burn looks like a little gray mark right across your hand, and it looks like you took the cookies out at 350 degrees without a mitten on. That's what it looks like. And it can be quite painful. You've done that. Has anybody else had a RF burn? Yes.
Aspect of the story. If you take a screwdriver and you do that, you can draw an arc off the end of the antenna.
Yes.
And it will not hurt you. It will absolutely astound, and everybody will think you're crazy.
Yes. I should probably start doing that. That's a good demo too. You can do that with 100 watts. You can draw an arc. With this in mind, guys, we have the impedance curve. So in the center of the antenna is minimum impedance. If this is free space, I'm sure the answer for most of you will be 75 ohms. But again, we're going to use 50 to 75 ohm coax here. At the ends of the antenna, you notice 3,000 to 5,000 ohms, very high impedance at the ends. Any questions on the curves? Remember, this is at one frequency. Anybody in here operate on one frequency? None of us. We go up the band, we go down the band. That's why we have our tuners. And all I can say at this point, I'm not going to get into it deep, these curves change. Okay? All right. Basically, that's what your radio sees when it looks out into your antenna. Since none of us can make our antenna out of silver or something that has zero resistance, we use copper, we use aluminum, and it has a certain amount of resistance, which we call our sabot. That's our ohmic resistance of the antenna, and some other things are sabot. Ground loss. How about that chain link fence under my dipole at home? How about the gutters? How about my neighbor's two big metal houses that he keeps his snowblower and his lawnmowers in? How about your aluminum siding? You know, we all live, most of us in here live in the city in these little lots, and we have a lot of stuff going on with your antenna that you don't realize. So the best we can do, put it up, tune it the best you can, and have fun. You know, that's the idea here.
Ron?
Yes?
I have mine in the attic with about 4 other antennas.
He
and
does.
all the piping and everything, but it works.
He lives right down the street from me. Yep, you've had that for years, I know,
Yeah,
Frank.
no. Only thing I can do there where I live.
The next one is called radiation resistance, and it's a fictitious virtual resistance. It's I still have students getting the ohm meter out thinking they can measure across the antenna and get 50 ohms. Radiation resistance, which if it's replaced by an actual resistor, would be 50 ohms on a perfect antenna. Very hard to explain. I go over some theories, 50 plus J0, and I have some, XY charts that I use in class, but I won't bore you with that here. Just keep in mind that what we're looking for at home on our antennas is 50 ohms. And now the two bad nasty things. These are the nasties, you know, reactance. I think it's kind of strange that if you got an antenna that's too long for the frequency that you want to use, if it's too long, then it looks like a coil and a resistor in series. It looks like an RL circuit. And the radio looks out and sees some resistance in series with some inductance. So what do you think your tuner does, guys? What do you think your tuner does? Your tuner adds some capacitance to create some capacitive reactance to, again, cancel it out. Same way as capacitance. If your antenna's too short for the frequency you're on, same thing. Your antenna is too short, you have capacitive reactance, then the radio sees an RC circuit, an RC series circuit, and then of course what's your tuner do? Adds some inductance and tunes it out. Now any questions on the circuit for an antenna here? Okay. Now, a lot of ways to mount a dipole. Horizontally, and you guys know that you can only get bidirectionality if it's half wave up. So on 40 meters, half wave above the ground is what, 64 feet? I can't do that in my house. My neighbor Lee, we did it in his trees, but I don't have any trees like that. So all I can say is do the best you can. Anytime you mount it lower than a half wave, your pattern starts going, well, oval on you. Guys, this is what I do. I just absolutely love the inverted V. Nearly bidirectional or omnidirectional. One support. When I was working overseas all my life and training people out in the bush, the desert, the jungle, that was my antenna of choice for HF. And we still do it today out in Bull Run Park. I take my students out and we actually have the insulators about that far from the Virginia clay. It's a great antenna. Anybody done a sloper? Yeah, they're kind of one direction. You can get a little bit directionality out of it. The one that makes no sense at all, vertical dipole, I don't like that, and usually I put a circle with an X through it. Vertical dipole, because you're really supposed to bring your coax out a half a wavelength, so let's just say problematic to mount, okay? Here's the inverted V. Now if you take this inverted V and put it out like this, you get this pattern. The inverted V gives you a pattern something like that. And I found at home that 120 degrees is what mine is, and it is absolutely right on 50 plus J0 at the frequency that I designed it for. I have two poles. First off, my inverted V is up 28 feet, and then two poles, one on each end, which is 7 feet high. What's the significance of 7 feet? Anybody know?
You can get electrocuted.
Exactly. People can walk under. My gardener can mow under it, you know, and people can walk under it. Kids can walk under it. Dogs. Nobody's going to touch it while I'm on the air. Exactly. So I just bought two 10-foot poles, 3 feet in the ground with cement, and it supports. Paint them black. Can't see any antenna from the street. But I just love the inverted V. Okay? Any questions on the V? Yo.
Yeah, you said yours go down to about 7 feet up.
Yeah.
But what's optimal for something like that?
Oh, well, greater than 90. Don't ever let the inverted V angle be less than 90.
With each end down there.
Optimal angle?
Do you want to get it as high as you can? Or?
Yes.
Okay.
Yes, absolutely.
What will happen if the angle will be less than
The what?
What will happen if the angle is less than 90?
Oh, it screws up the pattern considerably and the impedance. Yeah, mine's 120. Man, it's just perfect.
Isn't that the insulator you said for us to not use? Looks like an egg you've got on the drawing.
Well, no, actually not. No, that's an egg. No, that's not.
Okay.
And I maybe I didn't do that drawing, right? All right, next. Okay, I did that drawing. There you go. Guys, this is a super easy one to put up. Field day, picnic grounds, whatever you want to do. And what I have here, and I think I showed it before, but I did want to show you all. That center mast there is this fishing pole, which goes 18 feet. Bought it at Dick's Sporting Goods for 20 bucks. It's carbon. Absolutely fantastic for the center of the dipole. And I have a real nice dipole that I connect to it. And this is the yo-yo dipoles. Anybody use these? Nobody's used a yo-yo. Oh, these are great. Yo-yoantennas.com. Pull out what you need. If I need 40 meters, I pull out 34 feet. If I need 20 meters, I pull out 16 feet. If I need 21 megs, I pull out 11 feet. And as you can see,
I've still got an old slinky antenna.
Slinky, I remember those.
Oh, yeah, slinky.
Now, one thing about this, everybody says, well, wait a minute, how about all that wire inside? Doesn't that react with it? It acts like one big brick wall. The radio wave goes down that far and stops. One big Xabel in there, just stops. Okay? Guys, these are worth getting. This is a real nice little package for your go-to kit. Because I've got 80 through 2 meters right here in my hand. 80 through 2 meters, right here. Okay?
That's cute.
Oh. Tent stakes on the end. 4 tent stakes. And you notice I have 2 guy wires here. And the other 90-degree guy wires just happen to be the antenna itself. And this is just, I use cable ties on the way down. And then maybe you pitch a tent here, run your radio into the tent, and you have yourself your antenna. Okay? Here's one in a tree, the old oak tree. And why a pulley? Why a pulley up here? What's that?
Lower it.
To lower it, raise it. And guys, I don't know if you've ever tried to take an antenna out of a tree after even one growing season here in Virginia. You know the bark will grow right over.
Yeah.
So guys, I have this up in my tree at home. Antennas on it. Anytime I want, you know, hurricane's coming, ice storm's coming, I lower that sucker, put it right on the grass. Wait till it passes, the next morning I go out, raise it back up. This is a must. Notice here, notice on the ends there, on this Field Expedient antenna, no insulators. What's going on there? I'll just zip this, and let's see, let me take this here, okay. No insulators. This works quite well, by the way. This is Dacron. So if you're ever really in a hurry to put up an antenna, you take the end of your dipole, make believe that's the end of my dipole coming out of the tree, and you make a little twist here, and you tie All of us in the Navy, right, Mike, know how to tie these knots, right, Mike?
Clove hitch?
He usually asks the chief.
This is a sheet bend. This is a sheet bend with a slip. Now, does everybody agree that's not a conductor? There's my wire, there's my insulator, and this goes right into the tent pole or a tree or whatever. And everybody that I trained overseas, I use this knot. You know why I like it good? Pull that. Just pull that. We're out of town. We can take that antenna, drop it, we're out of there. Okay? That's a real nice knot to know. It's called a sheet bend with a slip. I know about 50 knots, and some of these come in very, very handy for antennas. So this is what's right there. Any questions, guys, on that? Okay. Anybody built a Pegote del Gato? Nobody works for the Medellin drug cartel in here. Okay, good. Glenn, I know you built these. This is pretty cool. I built one with 5 frequencies on it. Everybody know how this works? It's kind of ingenious. Let me just go through it. 3 frequencies: day, night, and twilight zone, or your transition frequency. It's on the same piece of coax. What the heck? Well, let's get electronic again, and let's say your radio puts in 7 megs up to the antenna. Okay? 7 megs goes up there and looks at the 3.5 meg dipole and says, oh my God, it's too long. Exabel, a couple of thousand ohms of inductive reactance. It's like running into a brick wall. 7 megs goes up and looks at the 10 meg dipole, says, X sub C, too short, another 3,000 ohms. 7 megs goes up and looks at the 7 and goes, whoa, 50, path of least
That's just right.
impedance. And it uses that antenna. Yes, there's a little reaction between the other two tuning it. Lee and I made one for field day a couple years ago. We were in his backyard for hours trying to get it right. We did, but it for people who want to run 3 bands, and if you got the room, the cat's whiskers are a good way to go.
Great for an attic dipole too.
Absolutely, yes, good for an attic dipole. Got what?
Can you make it an inverted V for all the circles?
Yes, you can. Yes, you can.
Ron, do they have to be straight? Can you make a V out of them?
You bet. You can do an inverted V. Sure. Okay. Good. Little construction. I know Pete wanted me to build an antenna in here and tune it, so we might even have time. And I'm not going to do 160 meters. We'll, I think 6. 6 will probably be good for inside here. What do you think? Okay. In the last session, I went over things to make your antenna with. Zip cord. Nothing wrong with zip cord, except after a few seasons, you guys realize that this is not IR, and it'll probably deteriorate. But yes, I do. I have used it in the field before. I've used it overseas where I can't buy copper weld. You ever try to buy antenna wire in Sierra Leone? Yeah, they don't have it. You see, there's no Radio Shack in Sierra Leone. You know what I'm saying? So, so I went and got this, and we made the antennas out of good old. You guys know it as lamp cord. Actually, we call it zip cord because it unzips, and it works just fine. Okay. Hard drawn copper. Pretty hard, guys. I don't like to make an antenna, and boy, I'll tell you, you kink this while you're pulling it out, you're dead meat. Forget it. Copper weld, I think I told you all what I think about this. This is copper-coated steel. It's very springy. Please, if you're using this, wear safety glasses. It'll come right back to you in your face. And I found that when I leave it out more than 3 or 4 seasons, the rust where you've dinged it, the rust will come through and you'll get a bad connection. So I quit using this completely. And now I'm using Flex Weave. Flex Weave is absolutely outstanding. 156 strands of pure copper. And if it breaks, splicing it together is very nice, very easy to do. Okay? Any questions on that? Got the dog bones? Thousands of insulators. Big long ones, big heavy duty, plastic. This is all we had when I was a kid. It was porcelain. I don't remember any plastic. This porcelain, go way back. And this is what I'm using at home, just these small ones. Mainly because you can't see from the street, it blends into the forest. Even though I don't have any HOAs in my house.
Ron, would PVC pipe work just as well?
PVC's fine. Sure, go for it. I've used a spoon. Yeah, I took a spoon out of an MRE kit and drilled it and used that for an insulator in Somalia. Yeah, it's surprising me what you can do. Guys, I don't know if I mentioned it last, those of you that attended the first session, don't use these on the end of your dipole, okay? If you're using wire for a guy. If you're using nylon, it's fine, but wire is a guy, because you notice it's like this. So you get a heck of a capacitive effect from the wire guy on these. And you know the purpose of these originally? If it broke, the antenna didn't come down. That was the purpose of these. But hey, you just don't see anybody using these anymore. Okay. Polyester, polypropylene, Dacron, or OD. OD means olive drab. I like the Dacron. This is IR. This is OD, olive drab. 550 cord, which used to be military. We used to call it parachute cord. You know you can buy it in Lowe's now? That's where I got this. This is IR, reflected. What did I say, IR? UV. Thank you. UV protected. So is this. This is also UV. This is my favorite, guys. This is the best right here. And I get this from the RF Connection in Gaithersburg.
What is that kind called?
This is a weaved. I can show you on the website. It's got about 3 words, and that's this is a nylon, but it is UV resistant, and I've had mine up for 5-6 years now. Okay.
Say, Ron,
Yo.
don't you have a problem with nylon stretching?
Yeah, it stretches, but I like it to stretch because the beech tree, back and forth. The knots I tie on the end are taut line hitches, and all I have to do is go back out and tighten it up a little. I just don't want it so hot, so tight that when it goes in the breeze, it'll break. Coax, guys, as you know, you've probably attended one of my briefings before. I could talk about coax all day. So let's get into this a little more. What's the most popular coax in here you guys like to feed your antennas with? 58? 213?
8X.
What's that?
8X.
8X. Boy, 8X is catching on, isn't it, Mike? Everybody's using that stuff. Now, Mike called it 8X. I wouldn't think of calling it 8X because I don't want you to go out to eBay and buy some cheap crap E8X, okay? Don't go buy 8X. If you're gonna go buy 8X, go buy some LMR 240 or LMR 400. This is LMR 240. double shielded. And make sure when you buy LMR 240 that you buy the LMR 240-UF for Ultraflex, because if you don't, guess what you're going to get in the mail? You're going to get a solid center conductor in the mail, and boy, you're going to be upset. Okay? Does this require special connectors? Yeah, of course. But I have all the crimp tools for all these. So I'll just pass these around. Anybody using 213? RG213, good stuff. RG213, single shield with a very nice polyethylene dielectric and 7 strands in the center, 7 strands. Great cable, okay? Again, guys, don't scrimp on this. Don't buy the knockoff stuff, and eBay's just full of the knockoff. Get Belden, okay? Or Times Microwave. Get the good stuff. Like I said before, you go out and spend $5,000, $6,000 for a radio, and then you buy crap coax. I mean, what's that about? Here we go. And now my favorite coax of all of them is the double shielded, either LMR 400, UF, or Belden 9913 F7. That's what I use. This is double shielded. The second shield is aluminum foil. Nice flexible center, 7 strands. Now, if you all went to order the connectors for this, you've got to say that you're using 9913 F7 because the center is just a bit bigger, so you have to order bigger pins. So if you're putting it on an N connector or a PL259, you're going to need a special connector for that, okay? And I see that happen all the time. People order the wrong connectors. I get these emails from the field, oh, it doesn't fit. That's the way it goes.
From your Raytheon people?
You betcha. Happens all the time. Any questions on coax? Okay. And connectors. I gave a demonstration of connectors earlier, I guess that was last year. No, this year. We did some soldering in the next room.
Yep.
These are pretty much the top 3, and guess what's taken over now, guys? Oh my God, you buy a walkie-talkie, what's on your walkie-talkie? The Sure Mighty Awful, the SMA connector. That's on your radio nowadays. And the worst part of it is that the radio has a male connector on it. The antenna has a female, which means you're going to twist the antenna on, and every time you twist the antenna on and off, you're wearing away part of the male pin. You're wearing it away. So guys, to a minimum, antenna on, antenna off, antenna on, antenna off with the SMA. Do it to a minimum. Because your radio will still be good, and that connector will be wore out. So guys, this is the PL259, the solder one, and here's a crimp one. Okay. Then we got the ends, best connector ever invented, the type ends. We use those for VHF and UHF. I have a solder one if you guys would like to look at that. And then I have a crimp one. Now, this solder one, this took me about 20 minutes to put on. About 20 minutes. You know what they call it in the catalog? It's called a quick connect. What? Quick connect. This one is a crimp, and I do it all the time in class. I have my students time me. I can put one on in 90 seconds, full mil spec. Okay.
Why don't you like SMA?
Too small, problematic. Students break the pins, they cross-thread them, and oh, by the way, what's the torque on an SMA? 8 inch-pounds. I got a torque tool just for SMAs, 8 inch-pounds. What do you think some of my students do? You put on an SMA with this,
You'll never get it all.
It's not gonna wear out.
It won't, it's on forever, you bet.
In other words, their torque is back, turn it to strip it and then back it off and have it turn.
Back it off, yeah. Guys, another demo I give in class is the difference between a half a turn on an SMA is the difference between contact and no contact at all. But this is what, it's $120, but it is 8 inch-pounds. You torque it down. The SMA was made for one reason, guys, for connecting waveguides to circuits. It was made to torque down. Okay, leave it alone for 40 years. Okay, we're done here. What do? On, off, on, off. They're only guaranteed for 25 to 50 mating cycles. BNCs are guaranteed for 500 to 1500 mating cycles. Anyway, the SMA is your generation. It's the new generation of the younger people in here. That's what it is. I hate it, but
Mine goes directly into a BNC converter, and then
beautiful. What he does on his walkie-talkie, puts a converter on there right away. That way he's gonna save the radio. That's a good idea. Okay, guys. Center insulator or balun? What do you guys do? Balun. Okay, everybody's using the balun? What's the purpose of a balun? And actually, this is what we call a choke balun. I don't use a ferrite balun. Does anybody use a trifiller or a bifiller balun in here? Oh yeah? I wouldn't think of it on a dipole. I wouldn't think of it. Because they, oh okay. Because they do saturate. These can get a little warm. I took one apart for you guys. This is a W2AU balun that has ferrites. First off, let's go back. Why do we need it in the first place? We really don't need it. We can get on the air and do quite a nice job. I've hammed in quite a few countries where I never put one up. I just went straight coax right into the old antenna and it worked fine. So we're being really picky here, but why do we need a balun?
The RF off your feed line.
Okay, so you're talking about unbalanced currents. Currents that are the imbalanced currents caused by, okay, the chain link fence and the ground and all kinds of things. So, because it's not a perfect world. Well, guys, anybody use this? This is what I have in my dipole at home. So I took it apart, Ray. 47, count them, 47 ferrites. And the idea of this is to keep what we call I3. I3 is I2 minus I3 creates I4 down here. Instead, what we would like would be I1 and I2 doing all the radiating. You're gonna have some trying to come back down the outside of the coax. This chokes it. This is what I use. I'll pass this around if you guys have never seen what's in one of these. That's what's in it. I busted that up this morning.
with the help of weather, didn't you?
With the help of a tree, actually. It was in the garage, so I thought it'd be a good training aid. All right, let's make a dipole for 6 meters. We have time, right? Okay. 6 meters. Anybody on 6? Yeah, sometimes when it's open, right? Yes, well, that's supposed to be for 160 through 10. Yep. So we're going to take 468 over the frequency in megahertz. 468 over 52 is 9 feet. So we have 4 feet 6 inches coming out of each end. 4 feet 6 inches. So I've already got one almost made up here. No, I'm not using a balun. I'm using, anybody seen these? Very nice for hoisting up in the tree, and I've already soldered on the center. So we'll What would we do without cable ties?
Twist ties.
Duct tape.
Remember, we used duct tape before. I always thought transistor was the greatest invention of the 20th century. Cable ties and heat shrink tubing's right up there, man.
Yeah.
Okay, you hold that, Scott? And here's what we'll do. I wasn't gonna do this, but Pete requested that we make an antenna anyway. Okay, hold that. 4 feet 6 inches. From this length of the wire. Yes, hold it right there. Very good. So we have 48. Right here. Okay.
The weather's not bad enough, this antenna will never work.
It'll never work because
You have to do it outside in bad weather.
that's right. You guys know that, right? The colder it is, the better it works.
Absolutely.
Now you notice I'm not going to torque it down all the way. So Scott.
So Ron, there was a question, did you make it 4 feet 6 inches? or
Exactly.
Not a little bit longer to wrap around the insulator, okay?
No. I made it 4 foot 6 inches right
Right
here.
there,
Yeah, to the turn.
To the turn.
to the turn, not to the length.
Oh, you got it. Go ahead.
Can't use the other side as the, matching to the other side.
It's too stiff, because I soldered. It's too stiff. No good.
See, that's stiff, when you solder like that, that breaks down after a while.
It does.
You don't wanna solder those joints.
You have to solder.
No.
Stays together. What do you do?
Wrap it, and then pinch it off, and I use metal
Oh,
clamps that
I wouldn't think of that. No, I wouldn't think of
works
it.
like a
Or a
charm.
Burndy connection.
You could. I've soldered for years. You gotta remember, I could probably take my antenna down and replace it every 2 or 3 years.
That's the balance.
But, geez, you have to solder. My God. Make a
Does the
connection.
solder break down? 'cause the
Yeah, but
metal
Terry,
is
this is
for-
copper.
I know, but it'll break, I mean, the
Copper will
it'll,
find-
it'll break, it'll cause
Have
that
you ever
to
just
fracture.
twisted copper
Cause you're
into
making
C
that
sharp?
point really hard, real stiff. Breaks down.
Works for me. Hold that. Okay, and then we're gonna take a couple of these.
Learn my lesson.
Yeah. Put this in here.
Ron, can I ask you a question while you're doing that?
Please.
What's the math associated with putting 47 of those beads for the ballon? Is there a formula for that? Why 47?
How much
Why
inductance-
47?
How much inductance do you need?
Okay.
That's all it is, you're looking at the inductance.
Okay. Just a certain amount? Is that as many as feasible? Mike, how many is the best?
Who knows?
Okay, all right.
I would say 47.
How many can you afford?
Yeah,
I just wondered how they.
something like that.
How they come up with that number?
Okay.
They're just, what they do is they're looking at
And we'll do this.
the total amount of inductance that you need.
What were the numbers?
And I'm just gonna have a couple
It's a
people hold
polymer
these.
part.
Scott, over here. And I'll have a couple people hold
It's a
them on each
ceramic.
end.
No, it's
What knot would you use here, guys? Good old, I use a bowl. And of course, I would cut this with a hot knife.
Toroid with one turn.
Okay.
That's what that is.
Now I need two
Said it's
people
like
to,
a toroid ferrule with one
one
turn.
on one end.
That's what I wanted to
You
know.
need to know what the ferrule material is, what the
Okay.
permeability is.
This is gotta be math.
Now, guys, I've never tried this inside. This ought to be interesting.
What the frequency that you just want the inductance to be a big number, 500 ohms or 1,000 ohms or something like that.
we can almost guess it.
It's like approximation.
So I'm sure his antenna analyzer is gonna say this is.
Oh, we will.
50 ohms.
Now, why haven't I soldered yet? Why haven't I freed up the ends? Because I haven't tuned it yet.
You mean on the meter?
Okay, guys, this is my new one. Man, what a piece. This is a Comet. This is the best Fizzwire meter I've ever had. I got rid of my MFJ. Of course, these are $600, guys, but, do you think I bought it? Okay. All right, hold it up. I'm not getting any resonance at all. Uh-oh.
Bad cable.
There we go. Okay, the best I can get in here is 4 to 1. Probably because of, I'm getting a dip, but look what's going on in here, guys. Metal, blackboard on all this stuff, but I am getting a dip.
What if you rotate them, say 60 degrees, so you're parallel to something else?
Why don't you go around here? Yeah, let's try that. Okay, all stop. Same thing, 4 to 1, guys. 4 to 1 and 50 ohms.
I've got enough coax for them to go outside.
So anyway, let's just say if we weren't resonant, I can get this thing, like out in the forest or my house, I can get this almost to the hertz. This has a digital readout, guys. And I go down here and snip, go down there and snip, and just keep getting less and less and less. Pretty soon you get right on your resonant frequency. I have my antenna lowered at home. And then what I'm gonna do is wrap this and I'm gonna solder it, unlike Terry. Still gonna solder it.
Hey, does your fancy meter tell you whether that's inductive or reactive?
No, it does not. Only visible.
Oh man, it's really a fancy one.
I've got that one in the office. Actually, Terry, I could care less.
But you don't know whether to add wire or short or take.
Well, I can tell where it's resonating.
That's all. But you don't know whether to add wire or take it away.
This is true. This is true.
If it's too high or too low.
That's, yeah, but you don't know which way to go.
You know, I've got the AEA for that. I have that one. It's good to have a couple of these, by the way. A couple of these different ones. And now,
That'll last forever. Last forever.
not me. Gary, you go ahead and do it, but I'm not. And I teach this for a living. I solder my antennas. I'm sorry. Guess? Butane is the best? You all have a butane iron?
Good.
These things rule, man. Speak about hot.
Lighter fluid.
No, this is butane, not lighter fluid. You have one of these?
Ron, the next time we won't invite Terry to your demonstration.
No, I'm not coming if Terry comes. So guys, here's what I do. And I know the solder will break down, but in this case, it doesn't matter.
A RTV solution.
Okay, now what actually, Tony, what I would do in this case now, I would take heat shrink tubing and put it over with an adhesive, a heat shrink tubing with an adhesive on it.
I think the ARRL manual says so. Sometimes the code.
Oh, okay. There we go, guys, right there, soldered. Then I would put a heat shrink tubing on it that has an adhesive. Bring it in there. That thing will stay nice for years. So,
Ron?
yes,
When you're in the process of getting it the right length, and you have excess wire on the end,
yes.
does that have any effect on your?
I like to kind of, twist it, put it down here. It has no effect at all.
Okay, you don't let it hang down or
No,
anything.
don't let it,
Just
don't
make
let it
sure-
do this. Make sure it's linear on this, around here, okay? You betcha, because that does have quite an effect. Okay, and you see the last one here is operate, have fun. Anything else, guys? You're welcome to come up and take a look.
Can you do anything for strain relief on the connector?
Oh, absolutely.
So what do you do?
At home, I have a piece of nylon that comes down and ties into here and does this.
No, okay.
Because you know, if this was 40 feet,
It's a lot of weight.
oh, a lot of weight. Guys, that's something you gotta think about, is the strain relief. And would I ever leave it like that? Oh my God, no. We're gonna wrap it with tape. We're gonna wrap it with, what I use is self-amalgamating silicone. That's what I use. All right, guys.